Hi guys, assalamu alaikum. So let's solve the question number 14 from the year January 2021. This is a particle physics question which is related to special relativity of Einstein. So let's solve this question. In the question they have said the moons are produced by cosmic rays in the Earth's upper atmosphere. Okay, this is not an important thing that we should be concerned of. In the next line, they have said in 1940, Bruno Rossi and David Hall made observation of the decay of these muons. So these muons were decaying. They measured the number of muons reaching the bottom of a mountain and the number reaching a position 60 meters higher up the mountain. So the thing is, the muons have started from 16 meters higher up in the mountain, and they will start to decay. And after decaying, they will travel towards the bottom of the mountain. So the thing he is calculating is how many numbers of muons are reaching the bottom of a mountain. So the muons were traveling at a speed of this. So this is the speed of the muon. So 0.994 into c. This means we know c means 3 into 10 to the power 8. And 0.994 means it's less than 1. It is less than 1. 0.994 is less than 1. I can say it's around 99% of this 3 into 10 to the power 8, because we can also write 99 divided by 100, which is equals to also 0.99. So it's quite similar to this as well, right? So we can say the speed of these muons is 99% of the speed of light. So it is traveling close to the speed of light. It is traveling close to the speed of light, which is 3 into 10 to the power 8. As it is 99% of speed of light, so we can say it is close to the speed of light, or it is actually traveling at the speed of light. And we all know, according to special relativity of Einstein, that according to special relativity theory of Einstein, that the faster you move through the space, the slower you move through time. Slower you move through time. So the thing is, the faster you become, the slower your time goes. Okay, you can also explain it using this formula as well. Speed is equal to distance divided by time, though it is not related to the special relativity formula, but still you can look at it like now, that if our speed increases a lot, then our time decreases. So as you get faster, your speed increases, so you become slower through time. We can also explain it through this as well, though it is not related, but I'm still making you guys understand through this formula so that you guys can relate to this more easily. So they have said that this is the speed at which the muons are traveling, and we can say it was traveling at the speed of light. So as it was traveling close to the speed of light, it was traveling so fast, so we can say the time became slower. So here we can say Rose and Hall found that 74% of the muons detected at 16 meters, the amount of muons that was detected on 1600 meter, out of them 74% reached the at bottom. So we can say 100% were at this position, and out of this 100%, this 74% reached the bottom. So we can say majority of the muons has been able to reach the bottom of the mountain. So we can say they were traveling really fast. That's why the time become slower, and they could travel very easily, because their average lifetime of muons is very less, as they have a very lower average lifetime. They shouldn't be able to reach the bottom of the mountain, as reaching the bottom of the mountain will take a lot of time. Just why they are able to reach the bottom of the mountain? Just because they are traveling at a very high speed, and that time has become slower, and suggested that the observation could be explained using ideas from relativity. explain whether these observations are consistent with the ideas from relativity, you should answer include a conclusion. So the conclusion that we are going to add right here is, this note is really important. Kindly jot down this and try to remember this every time you guys encounter this kind of relativity related questions. So let's move forward and answer this question. In the question, we also need to include the calculation. So the calculation will be the time, how much time it took. We have got the speed and we know the distance of 600 meter from the bottom. So the distance is 600 meter and we know the distance. So we can be able to find out the time taken to reach the bottom. So let's go and find down the time taken to reach the bottom. We know time is equals to distance divided by speed, which is 600 meter divided by 0.994 into 3 into 10 to the power 8, and the answer will be 5.37 into 10 to the power minus 6. So it took a very less amount of time. Right now we can, as we have found out the time, now we can write about the other things. That we can say, as this speed was close to the speed of light, we can also mention it, that the speed of the muons were close to the speed of light. The thing I have previously make you guys understood. As there is 5 marks, we can write 5 points. The third point will be, we all know, just because of been traveling at a very high speed, its time became slower, and that is the main reason why it could reach the bottom of the mountain. Otherwise, just because of this average lifetime, which is very less, they couldn't have been able to reach the bottom of the mountain, as their average lifetime is very less, and their time taken is really high. This time taken, the time the muons take to reach the bottom is greater than their average lifetime. So how did they been able to survive this amount of time? Just because they was really faster and the time becomes slower for them, they could reach the bottom of the mountain. So let's go and write it down. The muon could reach, sorry, we should not write this. The muon would have decayed much earlier than reaching the ground if it hadn't traveled at the speed of light, or through the relativistic speed, or through the relativistic speed. Both of them are correct, but as they have asked us to talk about the relativity, we should mention this line. It will be more appropriate. But you never know, in your exam paper it might ask about the speed of light, so you can mention both of them. It's better to learn both of them. So let's move forward and write down the D number point, which will be, their lifespan increases as the time becomes slower. Their lifespan increases. Their lifespan has increased, right? It was 2.2 and they have traveled this amount of time, so their lifespan has increased. So we can also mention that thing, that their lifespan increases when you travel through relativistic speed, And the last point that we are going to mention is the E point we will mention. This is why the muons reach the bottom of the mountain. So we are done with writing 5 points, and these 5 points are enough for you guys to get the full marks out of this question. And this question this question is really common and it might come in your exam as well, so it's better to learn this answer by your heart, and understanding this concept is really important for you guys to conquer the May 2024 exam, or maybe in October 2024 or Jan 2024.